Hey Zach, this is Prasant here.
Hey Prasad, nice to meet you.
Yep, let me turn on the video. I think like the blue jeans changed the screen, so I'm just searching for all the buttons.
Fun. Mine hasn't changed yet.
There you go. But they just moved it to the top of the screen now.
Weird.
That's a pretty background stage.
Thanks.
Lots of fun.
Important in the winter when everything outside is definitely not green.
Yeah, you see my room, it has been taken
Nice.
over by my kids.
Yep.
They decided to leave the chair and table for me. I don't know when they're going to take that away.
Yeah. All right, so Greg can't make it, as you know. We go ahead and start.
I'm sorry, I missed that. So are we
Sure, go
waiting
ahead and
for?
start. I don't think we're waiting for anyone else. Go ahead.
Do you want me to start?
Yeah, go for it. Go ahead.
Okay, sure. Let me share my screen. I hope I don't have any Netflix windows open. Can you see my screen?
Yep.
Okay.
Just the blue jeans window so far. There we go.
How about now I just turn that into presentation mode?
Yep.
Okay. So yeah, so this presentation is going to be about flake analysis, like the service that we have that you could use to automatically detect flakes or false positives in your test failures. So, I mean, this is a testing theme, so you guys would probably already know about like flakes. So it's anything that I mean the test fails, but still like it's not actually a bug. I mean the software functions correctly. So how do you go about detecting them? There are like a number of ways, but the one that we implemented now is like using machine learning. That's based on clustering and classification algorithm. So if you wanted to use this technique, and ideally if you want to use machine learning, then you would go about implementing the machine learning code, choose the right infrastructure, the storage backend, like a lot of those stuff, and that could take time. So what we have here is like we take care of all those stuff. Like we already expose that as a service. So all you need to do is like upload your data using the REST API call and then get the analysis done. So it's as easy as that. I'll go over the workflow of like what the infrastructure looks like in the backend. So we use Ceph for the storage backend, like that's to store your training data set or your test failures, etc. And the code itself, it runs on OpenShift cluster. So the machine learning code, like training the model is quite computationally intensive. So we trigger that as a separate OpenShift job. And what actually interfaces with the API call is the OpenWhisk. It's a serverless platform that actually receives your REST API calls to either train the model, or like predict whether a test failure has flakes or not, or whether you want to pull the status of a particular job, like was the training completed or what's the status of the prediction. So things like that. So we use OpenWhisk for those. That's like an overall view of the infrastructure. So how does the REST API look? So all you need to do is like point to the right endpoint. In this case, we already have it implemented, like the flake analysis training or prediction. And the name is something unique that you would pass on just so that you could keep doing that repeatedly. And the S3 path is nothing but the data that you actually upload to the Ceph backend. So in this case, the test learned would something be the training data set, and the test failures would actually be what you want to predict on the current set of failures. So let me show you a sample training data. So this is just one failure data in the training set. So you would have a lot of other failures too. So so obviously the status is failure, and it has the failure information like the traceback or any other error messages. And another important thing is like you actually flag whether it's a false positive or not. It's based on a historical data where you have the test failure and you've recorded that as like being a false positive or not. So based on that, the system goes ahead and trains the machine learning model. So once the model is trained,
A quick question about the log here. Is this usually like just a traceback, or can you feed it a bunch of as much or as little context as you want?
or as much as you want. So I mean, I couldn't put all those in this one single slide, so I just snipped out all the other stuff.
Okay.
So it's huge. So I'll show you the actual
Okay.
data like once I'm done with the presentation. But yeah, I mean, the log file could be anything. It could be as huge as you want. I know like usually it runs into pages, so it could be any amount of details. And so right now the cockpit team uses the flake analysis code, and what they record as false positive is any test failure that they merge even though it fails. So we assume that the developer considers that as a false positive. But if you have any other ways of doing that, that's fine too. Like all you need to do is like send historical data that has already been tagged as whether being false positive or not. And once that training is done, then you send in the new failures, whatever you see, and that the model actually takes that and then gives you back the result saying, oh, sorry.
Probability.
How do I make this disappear?
Wait.
Can you see that? Oh, yeah.
There it is.
Keep going. Oh, there you go. So when the model gives you back the results, so each of the test failures that you send would actually be appended with a probability value saying like, okay, this particular test has an 89% chance that it's a flake. Now it's up to the individual team to decide on the threshold. Now, if it's like what the cockpit team does, it like even if it's above 50%, they tag, okay, it's a flake, and we are confident enough to trust the analysis, and then we're just gonna rerun it instead of just going to deep dive analysis. So that's the gist of the flake analysis. So
I think my first question is, our log files are like megabytes in size, and then
yeah.
there's somewhere buried in the middle, there's going to be like a traceback. That's like the actual thing that failed.
Yeah.
That triggered the problem. How is there anything in there that's sort of trying to pick out the right feature? Because if all the other stuff is like, it's similar between runs, but it's a little different because they're different tests, and so there's different just
so
down and so on. Like, how does it?
Yeah, so right now we assume that the user is going to upload the data in the clean format, but I know like that's not possible because the data cleansing and the data pre-processing needs to happen. So I'm working on the library that does that, but I'll be happy to like work with your team, like see like how we need to clean up your data and kind of like push it to the Ceph backend. And I can work on that.
Like, is the idea that is what we should be doing, like finding the tracebacks, for example, in the log file, and maybe providing a bit of context around those tracebacks, and then using that as the
Yeah,
as the future that we're training against.
yeah. And not just the traceback or any information you feel that is relevant to
relevant.
like
Yeah.
triaging that particular failure. So
Yeah.
like the file names or any other context that like you have like the functional call flow or anything like that.
Yeah, so we could maybe, you know, we're talking about, are we talking about teuthology here, or are we talking about just,
Yeah.
yeah,
I
so
think
if we're specifically talking about teuthology, what we'd want to collect, you know, like possibly the entire job config,
mhm.
or at least, you know, large sections of it, because, you know, I think it would be useful to consider even things like what OS we ran on, um, and then grabbing the traceback plus as much context that's previous to that in the log file as is reasonable to store.
Yeah.
And then so we would put all this together and then ship it up to that server, and what training happens on like a scheduled basis or something is.
So right now it's not triggered. I mean, we just implemented that, and so we're just like pushing it out to different teams. So if it has to be triggered on a like a cron job, like on a regular basis, that could be done as well. Right now, the service just sits there idle. So yeah.
But at the end of the day, we have to provide sufficient data to actually train it, right? So I mean, stepping back a second, I think it's important to think about what we're talking about when we're talking about flaky tests, because I think there are two main categories that I can think of. One is that there is a teuthology test failure that has nothing to do with the test itself. It's like fog failed to provision the machine. I get those pretty frequently where just times out, it doesn't provision the machine. Or sometimes there's like a network failure or some other like hardware issue in the lab that just makes the test fail. It has nothing to do with the test being run. So we normally call those infrastructure failures. So that would be something that if we can identify those automatically, that would be great. But the other thing is that sometimes the tests are unreliable. We have bugs that don't trigger every time. So the test will pass 99 times and then the 100th time it'll fail. Not because it's a bad test, but because it's just a hard corner case to hit. But those we don't want to ignore, right? Or sometimes we have a test that's just flaky, like it'll pass, 9 times out of 10, but then the 10th time it'll fail because it's a poorly written test. Like I think those are things that we wouldn't want to filter out and train against because we want the test to be better. We want to see those failures so we know that the test is bad.
So we'd want to be really careful about what we submitted to this thing.
Yeah. And sometimes we see a test failure and we merge the code anyway because the test is in master, it's not in the branch, or the regression is in master, it's not in the branch, or because we know we're going to do a post a follow on or something to merge it or something like that. So I would be very hesitant to have something that's automatically merging or inferring that it's a flaky test that we should hide just because we merged it. Right?
Yeah.
Like we might know we have a flaky test and we're in the process of fixing it. Meanwhile, we're trying to merge something else in it.
Yeah, so I had a question that relates to that about the example that you showed us. I think, is it the merged true that's telling the system that it was a false? Okay.
Yeah.
Okay.
Yeah.
And is that kind of free form though, did you say? So could you define conditions, that meant that we're looking at a false positive? Or is that merged true thing magic?
Yeah, no, it's up to the user to define like what a false positive is. So, I mean, the cockpit team assumes like anything that the developer merges, even though it's a failure, that's a false positive. But I mean, how you present the historical data is up to you, and how you define false positive is up to the team. And as Sage said, like there could be failures which you expected to fail because it has missed the running the Bugzilla test or whatever. So yeah, I mean, if you want to skip those and kind of like record them as different, like yeah, it's up to the team as well. I mean, you can always go back and see how the model has trained and is performing on your new data, so that we can come back and see like if what you've done is correct.
It seems to me like sort of the minimum that we would need to do, or we can talk about what the minimum we would need to do in order to take advantage of this. I think that the first thing would be we would need a way to like explicitly say that this test failure is a false positive, in the absence of inferring it magically from whether it's merged or not. So either like some convention like you touch a file in the test directory, or if there's a button in Pulpito or something, where you make it read write. There's a button that you click like this was an infrastructure failure, and you like mark it. Something like that. Because then once we have that, then we can have something to train against. And then it seems, I guess the second half of that would be either the tautology itself at the end would go and query and see, does this failure look like a false positive or not? And it would record a score, and that score could be shown also in Pulpito. Does that make sense, Zach? Does that seem like?
Yeah, that seems feasible. So we'd want, let's see, we need to figure out what sort of component would be submitting the data, right? So if we wanted to do it through Pulpito, for example, like it might warrant a different service that Pulpito could ping and have it do it, or maybe Pulpito would do it itself. Just up until today, it's just kind of a
read only.
It's a dumb renderer of a different service. But yeah, I mean, in theory, that could totally work. And then, yeah, so tautology at the end of a job, it queries the system. Is that what you're getting at? To say,
yeah.
Is this failure legitimate? So tautology is not trying to submit itself, but it's asking how probable is this to be a false positive.
Yeah. Or maybe I'm a little bit unclear how the training versus querying, if they're explicitly separate. Like, do you explicitly provide a training set, train the model, and then you separately provide data points and you say, is this a failure or not? And it doesn't actually record it, it says stateless.
So the idea here, I mean, you could provide the entire data set, and I could probably like do the splitting of the training versus the prediction. But the idea here is like once you train the model, like for future prediction, you're kind of like sending in live data. I mean, as soon as the test fails, you're sending it to the model and
so it's accumulating. It'll be self-training from there on in. Yeah, I think that the trick is that we won't know we won't have a signal of whether it's a false positive or not until we actually go and a human looks at it. So I wonder if the first step in all of this is just to pick a way for us to consistently and reliably record that something is or is not a false.
Yeah, and
so we have that, then we're sort of.
Yeah. So can I ask, like, what kind of like testing do you run? Like, is it like you run the test again a merge, like a pull request, or is it like a functional testing, or?
It's like pull requests, yeah. Yeah, we batch them up at once because you can't run all the tests for every pull request. But
okay.
Yeah.
So the tests that we're talking about, like the tautology tests, they're not run, by like GitHub hooks or anything, right? So a human goes and merges a bunch of PR branches and then runs them through the system. That's what you're talking about, right, Sage?
Yeah.
I just want to make it clear that it's not like an automatic thing.
Not fully automated, yeah. Yeah.
So probably for the first step, I mean, we could use the same logic where like any pull request that was merged, even though the test failed, could consider them as false positive and then kind of try to look at the analysis and see how it turns out.
Mm-hmm. Another approach we could take is, so I haven't been close to this in quite some time, but we run tests for PRs and we do nightlies, and humans look at those to a certain extent, like Yuri, who's here, and we do have people that are pretty good at spotting, what's an infrastructure failure and what's a test failure. It's a process that we kind of do already. It's not exhaustive.
Yeah.
It's
Right.
not perfect, but to build a set of training data, what we could do is just, there's this one idea. We could say, whoever's looking at these tests, when you see, an infrastructure failure, maybe put it in this list, put it in this pile of things we've identified as infrastructure failures. Then we have a tool that goes and scrapes all of those and submits them.
Yeah, I
Just
mean,
as like a bootstrapping.
This is very similar to sort of the second, not directly related, but also big missing gap. And that is like, if we do a run, there are 200 tests that run, 3 failures. Somebody goes and looks at each one and figures out what it is. And it's like, it's one of two things. It's either it's an infrastructure failure and you ignore it, or it's not an infrastructure failure. It's like a test failure or a bug or whatever, in which case we should ideally actually link that failure to the bug that it maps to. And we kind of do that mentally, and sometimes we note it in the pull requests when we're commenting and we're merging stuff anyway. We say, oh, this is a known issue caused by this other bug. And sometimes we do it over email when we're replying to the stuff QA list, but it's all very ad hoc. We don't have any like actual tracking of that. So if it were me, if we're making like one user interface, it would be in Pulpito. As we're looking at these failures, there'd be a way to like, for each failure, you could say either check a box that says infrastructure failure, or we could fill in a box that has the tracker number or the bug that references that failure. Does that make sense? And that's,
that would be a superior solution.
One process. We have all that data. One of the things it could feed into is this, right? But it would also just be nice to have that tracking metadata anyway, so that we know that these failures are related.
Yeah, you're totally right. I'm curious. Does this system have the ability to, let's see, is it kind of just a binary thing where the question is this a legitimate failure, yes or no, or is there some dimensionality to it? Like, what type of illegitimate failure is it? Does it have that sort of concept?
No, right now it's binary.
Okay.
All right. Yeah. Number of
That's reasonable. I was daydreaming of like, if it could say, this looks like a network infrastructure problem, or this looks like the disk failed.
I think internally it's doing some clustering, but that's kind of opaque to the user, right? You can't see how it clusters.
Yeah, so I think like once you do the clustering, I mean, we can also expose the clusters and kind of do like a high-level topic modeling that says like, what does this cluster actually mean? So this could actually tell you whether it's like networking or security or like some other kind of problem. So maybe that's like the secondary level of information that we can provide.
Okay, cool. Yeah, just a thought.
Okay, so I have a couple questions here. Is there a limit on the content that we can feed into it?
Not as if I know, like it's a big server, so it's beefed up. So yeah, it should be able to handle a lot of stuff.
How big is big?
I haven't crashed it yet, so.
Okay.
Yeah.
Okay. So,
I think like even now, like the models that I'm trying, it's probably like 25 gigs, just the model itself. The data runs to like 200 gigs or something like that.
Okay.
So my understanding is that you load the content that has all these tracebacks into the server, and you're trying to query against it to find the false positives, right? And I'm just wondering, the tracebacks for infrastructure failures or similar issues are going to be the same. It's not going to be different for every failure. So wouldn't it be easier, like what Zach mentioned? People, whoever are hitting the network failure or infrastructure failures, they can go ahead and feed them into the log file, and we can just feed the log file into the server. Wouldn't that be simple enough? I mean, I understand that having Pulpido map the bug and all that is super cool, but for starters, am I missing something here?
So I'm sorry.
To do this at all, we would need to build a tool. Where that goes is another question, right? It could be something that is invoked by a Pulpito. It could be something invoked by a user, but we'd have to build it anyway. And I think Sage's point is just that this, this is something we want anyway, so maybe we should put it where we've always wanted it. It would be a little more, I mean, it would definitely be more development time to do it the Pulpito way, but maybe it's worth that time.
I see. Okay. I was thinking it was as simple as manually picking the traceback, putting it into the file, and feeding that to the server.
I feel like you want to avoid this being,
Oh yeah, totally. No, I get it, because I'm just looking at something we can do immediately. I have been recently I've been looking at some of the pathology logs that says the run is passed, but it has actually not even started running. So I was like, oh my God, that's not good.
That's a problem. That's like one of the biggest problems you can have with a system like this.
I'm trying to find one of the runs so I can just show it to you guys.
I'd like to see that, because that's a pretty big deal.
Yes. Yeah, I'll just share it on the USB later today.
So I have another stupid question here for you. Are you submitting only those things which are false positives, or are you submitting, other data as well?
So the training data would have only the false positives. So that basically trains the model to find out clusters, groups of failures that are similar. And when you start submitting new failures, like it could be anything, you can just send in all the failures and they're just going to find out the chances of that being a false positive or not.
Okay.
So doesn't the initial training set also need a bunch of non-false positives for the negative set?
So this is based on clustering, so it's kind of like grouping the false positives.
Okay.
And the second part of the problem is the classification. So that's when like it actually computes the probabilities.
Yeah. All right. Well, I made some notes in the pad. It still seems like the first step is just we need to reliably start recording this data, and we probably need quite a bit of it before we can have any meaningful, garbage in, garbage out, before we can have any meaningful predictions from the flake analysis. So.
Okay, sounds good. And if you need any help from me, like in preparing the data or like doing some cleanup, just let me know. I can help.
Yeah. Okay.
What would be a good size for like an initial set?
So I mean anything in the megs, like probably. I mean, I don't have a specific number, but it's just that like to see like how well your the model gets trained. Like the more the data, the better it is.
Not like thousands of data points.
Yeah, it's good to like hundreds, even hundreds, or is fine to start with, and then we can slowly keep streaming in the data and append it to the training set.
Okay.
Okay.
Just now opening the pad. Is there a link in here or do you have a link to your presentation, or where do we go to find out more?
Thanks.
Oops, I didn't know that I was muted there. So I pasted the link to the blog post. So it's on the chat screen.
Yeah, thanks. I'm opening that now. Cool.
I'll send you the link to the code that actually does that. That has and when you go there, you'll see like flake analysis. So that's the library that does that. I have other stuffs like to handle like data storage and other stuff as well. So
Yeah. Cool. Okay.
Yeah, this looks really promising. Hope that we can make this work.
Yeah. Yep.
I've
And
kind of
the good
daydreamed
news
about
is,
having this for a while now.
yeah.
And the fact that it's available as a service is really nice too. One less thing for us to worry about adminning.
Is the service available outside the firewall?
So what do you mean like outside the firewall? Like
The Ceph test lab that we're talking about is not part of the Red Hat network. It's in the community lab cage or whatever, community cage.
okay. So I don't think so, but yeah, we're gonna. So the other initiative that we're doing is like we're gonna push everything upstream, and we're gonna deploy this service in the MOC. That's like the Massachusetts
Yeah,
Open Cloud. So once that's almost there, so probably by this week that should be done. Once that is done, we
Okay.
could point to that
We do it there.
link
Perfect.
in panel one.
Okay, great. Yeah, because an internal only instance would be less than half as useful.
Yeah. Yeah.
But
Yeah.
that's good news. Very good news.
Cool. Cool. Okay.
So yeah, I'll probably touch base with you in like in a week and see like how things are going. And if you need any help, just let me know and I'll be able to I'll elaborate.
Sounds good. Okay. It's probably ambitious that we'll do anything in a week, but because I think before we can really start using this, we need to get data, which means we need to make changes to Pulpito and Nova, which has to be prioritized along with everything else.
Yeah.
Okay.
That's the tricky part.
Yep.
But thanks for showing us this. I'm really excited about this.
Yep. Me too.
Yep.
Yeah. Thank you. And
Awesome.
yeah, as I said, like feel free to like ping me like if you need any help or.
Hey, Prashant, where can we
Perfect.
find you on IRC or?
So apparently like our team decided to use like another different kind of like IRC like Mattermost. I don't know if you're aware of that, but I can paste the link here.
It's at the OpenShift chat.openshift.io.
Yeah.
Daniel's been evangelizing.
Yeah.
Yeah. All right. Cool.
Oh, I've heard of it, but I haven't tried it. I'll check it out.
That's my ID, so you could ping me there.
All right.
Okay.
Thanks a lot.
Thank you guys. Yeah, see you.
Thanks a lot.
Yeah. I see other stuff on this agenda. Is the stuff that this is the first time I've actually managed to join this meeting. So I don't know how we're normally doing it, but this other stuff we want to discuss.
Oh, that I think that there was this other guy who was discussing it last week, and I forgot his name. Kair and Zach were talking about it,
Okay.
and
Okay,
Nathan
cool.
Butler. So none of them are here.
All right. Oh, we'll just push this off to next week, I guess. Then let me just move it up to the next agenda. All right. Cool. Okay.
Anything else you want to say, Paige?
Sorry, what was that?
Anything else you wanted to discuss?
I don't think so. I mean, there's the larger issue of like how we're gonna do any of this stuff.
Yeah.
Especially with Zach doing, what's he doing? Metrics? Is he? I don't remember what he's doing. Metrics, yeah.
Yeah.
But in the meantime, we can still make a plan. So
I think if we can get this one done, the false positives, that would be like a dream come
Yeah.
true. You don't need any manual intervention.
yeah, there are a couple things. There's like the dead jobs not getting logs is super annoying. That wastes a lot of time. That'd be nice to fix too. But yeah, there's a whole list of stuff. This one would be pretty nice. I think this adding this UI that lets us provide some meaning to like what the failure means. Is it a false positive or is it associated with a particular bug would be huge. Or it's like unknown. I can't tell what happened here. I don't know what the problem is. All that would be. I think that'd be really valuable.
Train it, right? So it's not gonna do like automatically for you.
I mean, for a human, like right now we analyze the runs and we just like look at it and we say, oh yeah, that's that one I don't need to worry about, and then that's it, and we forget about it. But actually recording that information so that every time we see a failure, we actually link it to the bug that caused the failure. If we did that, we would have like an order of magnitude more data to work from.
We can generate a lot of test results or reports based on the nightly
right. We can prioritize bugs based on how many failures they're causing. We can just see that they're causing a bunch of failures. That would be really valuable. So.
Right now, people are scared to look into the failures because half the time they know that this is like not even worth looking at because it's infrastructure failure or something that's going on.
I mean, if I'm being consistent and good, then every time I see a failure and I figure out what bug caused it, I'll go look up that bug and I'll paste the path to the failure in the bug ticket so that when you're looking into a bug, you can see if it's still causing failures or if it seems to have fixed itself or gone away. Having that process happen automatically would be so nice.
Yeah, you can generate patterns and yes.
Yep. Knowing that this was consistently happening 6 months ago, but then stopped.
Right.
Like, oh, well, I guess don't need to worry about it. Or whatever it is.
That's like a lot of manual effort saved. Yeah, totally.
Yeah.
That is.
So yeah. Anyway. Cool.
All right.
All right.
So, since that you're here, I just bring up this topic. Looks like the nightlies have not been getting so much love recent times because of the PR testing that we're doing. And I was hearing from the downstream queue, like, for example, the 3.1 RC that they are testing, they have hit like a 90 plus bugs. And they are like, how come we never found this in upstream testing? So I'm kind of doing some analysis to find what kind of tests we are actually running upstream and what we are not. I know that we have like huge test coverage upstream, but looks like we don't have so much bandwidth.
Yeah, I think you need to look at what bugs they found in order to make sense of that. Because like for Rados, for example, I never look at the nightly Rados runs because I'm running pull request tests, merge master like every day. And so I see it every day plus a little bit. So I don't, looking at what's already merged is like less interesting or useful. I don't know how the other teams do it. Maybe on RBD and on RGW they make more use of them, but the automatic runs I never need to look at because I'm always running my own.
Mm-hmm. Yeah, so that's something I'm trying to figure out because the Rados gateway hit like a basic bug, and that's a blocker now for 3.1. I'm pretty sure we have the stocks test for Ceph Ansible, and like right now we have stuff because of Ceph Ansible. We have stuff a little bit distributed, and we are missing out something upstream. So, all right.
Yeah, I think we're not really testing Ansible upstream, which is also a problem.
Right. All right. That's all I had. Share more data when I have.
Okay. All
Oh,
right,
it's just the 3 of us. All right. See you guys. Good day.
guys, have a good one.
Bye bye.